Hey everyone, and welcome. Today we are diving into one of Python's most powerful and maybe sometimes misunderstood tools, the Lambda function. It's a real secret weapon for writing clean code, and by the end of this, you'll see just how much you can accomplish in a single line.
You know the feeling, right? You just need to do one tiny thing, maybe just once, and writing out a whole def function, giving it a name, adding a return statement, it just feels like overkill. It clutters everything up for what's basically a throwaway job.
Well, this is exactly where Python's Lambda function comes to the rescue. It's a function with no name. That's what anonymous means. It's literally designed for these quick, on-the-fly operations where a full-blown function is just unnecessary baggage.
So how do you actually write one? Let's break down the syntax. I promise it's way simpler than it might look, and seeing it right next to a regular function makes it all click.
This slide says it all. I mean, look at the difference. On the left, our standard add function. It works, but it takes 2 lines. On the right, the exact same logic, the same result, but in one single elegant line. Notice what's missing? No def, no function name, and no return keyword.
Let's look at the anatomy of it. You start with the keyword lambda. That's what tells Python what you're doing. Next up are the arguments, just like in a normal function. Then comes the colon, super important. And after that, you get one and only one expression. The result of that expression is what gets returned, automatically, no fuss.
All right, time for a quick pop quiz to see if you're following along. Take a look at this code. We've got a lambda named check that tells us if a number is even or odd. So what do you think happens when we call it with the number 4?
And the answer is B, even. If you got that, you're on the right track. The expression here is a ternary operator. It's just a compact if-else statement. Since 4 modulo 2 is 0, the condition is true, so the first value, even, is the one that gets returned.
Okay, so we know what a lambda is, we know how to write one, but the real question, the one you should always ask, is why? When should you actually reach for a lambda instead of a regular function? Let's dive into the practical side of things.
Really, it all comes down to keeping your code clean and readable. Lambdas slash the amount of code you have to write for simple tasks. Plus, you're not polluting your program with a bunch of function names you're only going to use once. But their true power, their real sweet spot, is when you use them with other functions.
And this is where it gets really fun. This is where lambdas go from a neat little trick to an absolutely essential tool. They are the perfect partner for some of Python's most powerful built-in functions. Let's look at the 3 big ones: map, filter, and sorted.
First up, map function. Think of map as an assembly line. You give it a tool, which is a function, and a conveyor belt of items, which is your list. Map's job is to take your tool and apply it to every single item on that belt.
Here's a classic example. We want to square every number in a list. Instead of writing a whole def square number function we'll only use here, we just pass map a super simple lambda. Lambda x, x to the second. That's our tool. Map takes it and applies it to 1, then 2, then 3, then 4. It's clean, it's efficient, and it's all in one line. Next up, filter. And the name says it all. Filter helps you sift through your data. You give it a function that acts as a test, it has to return either true or false, and filter will only keep the items that pass.
In this case, our lambda x, x%2 equals 0, is our test. For every number, filter asks the lambda, hey, is this even? If the lambda returns true, the number gets to stay. If it returns false, it's out. The result? A new list with just the even numbers. So simple.
And finally, my personal favorite, sorted. We all know how to sort things, but what if you need to sort by a custom rule? That's what the key argument is for, and oh man, are lambdas perfect for this. Take a look at this list of names. A normal sort would put Bob and Clara first because of the capital letters, but that's not what we want. So we give the key argument a lambda, lambda x, x.lower. We're telling sorted, hey, before you compare any 2 items, just make them both lowercase first. It compares Alice to Bob, not Alice to Bob. And just like that, we get a perfect, case-insensitive sort.
Okay, one last quiz for you. And I'll warn you, this one is a bit of a trick question designed to catch a really common mistake. What do you think happens when we try to run this code?
The correct answer is C, syntax error. And this is maybe the most important rule to remember. A lambda can only contain an expression, something that evaluates to a value. It cannot contain statements, like the return statement. The whole point of a lambda is that it has an implicit return. You never, ever, ever write the word return inside a lambda.
Now that we've got all the pieces, let's put them together and do something really impressive. We're going to pull off a complex, multi-level sort using just a single powerful lambda function.
Okay, don't let this line intimidate you. It's actually genius. Imagine we have data with names and scores. We want to sort by the highest score first, but if there's a tie, we sort by name alphabetically. Our lambda returns a tuple. The first element is negative x1. By making the score negative, we trick Python's sorter into putting the biggest numbers first. It's a classic trick. The second element, x0, is just the name. Python will only use this to break ties, and it sorts it in the normal ascending order.
And here's the proof. Look at the result. Alice and Charlie, both with 90, are at the top. And since their scores were tied, they get sorted by their name. Alice comes before Charlie. Bob, with the lower score, ends up at the bottom. All of that complex logic handled by one beautiful line of code.
So let's just recap the big ideas. Lambdas are anonymous functions defined with the lambda keyword. They are at their absolute best when you pair them with helper functions like map, filter, and sorted. And the whole reason they exist is to help you write cleaner, more efficient code for those simple, single-use tasks.
And that's really Lambda functions in a nutshell. It's a tool that, once it clicks, you'll start finding uses for everywhere. You know, it reminds me of that great quote from B.B. King. The beautiful thing about learning is that nobody can take it away from you. Hopefully this helped you learn something new today. Thanks for watching.